a few seconds for getting live. Announcing real quick. You can ask them for the Steam name.
Yeah, let me know once we start streaming.
Yeah.
Rage on that beat, going crazy.
Hi, everybody, and welcome to the stream straight from Barcelona, from the AI for Connectivity Hackathon Building Resilient Network Editions. We've got 3 teams that would love to present their projects that they've just submitted for the hackathon live, and we'd love to introduce them to you so they get a bigger audience to see their submissions. We still don't know the winners. The judges are starting to judge very soon. So we'll make sure to announce the results as soon as they are ready. And now I'd love to introduce the first team.
Thank you. So thank you for all the ones who are attending us here at NTT Data. And thank you also to the ones who are watching online. Thank you, Joanna. Thank you, Emmanuel. And thank you, LabLab AI and NTT. Without you, this couldn't be possible. So we are Eloy Lloveras and Aitor Murgui, and we are pleased to be here today to announce NRIC. So what does NRIC aim to achieve? What are NRIC goals? So NRIC aims to deploy a fully open source 5G network in remote villages and rural or suburban areas that currently lack of connectivity. So by leveraging open source communications and open source code, we reduce significantly the CapEx, and by leveraging also the cutting edge technologies, we optimize the OpEx costs also. Our key innovations in our approach is the deploy of an integration of a near real-time rig, which extracts metrics in real time, extracts the throughput, the downlink and the uplink throughput in real time in the nodes, in the GNODs or RAN, whatever you want to call it. And this allows us to deploy intelligent energy management automation. By doing this, we have efficient resource allocation, and that's the way that we can develop and deploy private 5G networks or public 5G networks in a sustainable way, which it's one of the most one of the biggest problems in these areas where they are underserved regions with problems, with cost problems, where the governments, for example, they don't see any profit on deploying a network in these areas, or, for example, they don't see the telecom industry, they don't see any profit neither on deploying in these regions. So our goal is to bridge the digital divide by providing affordable, scalable, and intelligent connectivity solutions. So this is the NRIC architecture. I want you to first focus a little bit on these logos that we have right here. These are the, let me put here so online can see also. These are the open source codes that we have used for our deployment. So Open5GS is for the core side, okay? So SRS-RAN project is for the radio. Both, I repeat, they are open source. And we have used the Lab AI models built and trained by us to establish that connection with the near real-time rig. And then with the trained model, we specify, the model specifies which is the concurrency, which is the power consumption that the radio needs at every moment of the, at every instance of the moment. And it is very important to know that all the radio on the RAN side is ORAN Alliance compliant. This is very important because being ORAN Alliance, we are interoperable with a lot of radios. We have a much higher scalability, and it's better at the long future in order to deploy multiple scenarios like this. So, wait, I wanted to delve a little bit in the architecture. If you know something about mobile telecommunications, this is a normal deploy of a mobile network. Here we have the user. The user connects to the radio, and the radio is connected to the core. So the core has a gateway to the internet. But here, what we have new is the E2 interface right here, which has the near real-time rig powered by the AI. So this is I wanted to put this slide here so you can notice the difference between a typical RAN architecture against the virtualized RAN architecture. And this is like the typical architecture that used to be in telco industry for the radio. And as we can see here, we depend on the BBU, which is a proprietary hardware, and this is more costs, less efficient, and it always scales worse than this scenario right here. But in this scenario, we have three options also. And this option, as we can see, it still relies on a BBU. It's virtualized, but it's still proprietary hardware, proprietary software, sorry. So this is still a problem right now. The second one, which is virtualized CU, but again, we don't have the virtualized DU. So our deployment has the fully Open RAN solution where we have virtualized the CU, the DU, and of course the RUs cannot be virtualized because you need something to radiate, and this is a physical hardware. And the Open RAN solution has a better interoperability, cost effectiveness, resource optimization, and it's more scalable and flexible. So here we've done a simple comparative in order to you to understand how this can save energy and at what point, till what point it can save energy. The red line that you can see is a typical consume of a macro cell. It's 200 watts per instance of time, okay? And the typical GNOBs, the typical radios, tend to work at the same amount of load, amount of consumption during all the day. So with our solution, we've done 5 scales: 10 watts, 50 watts, 100, 150, and 200 watts, okay? And we have divided the 24 hours of the day into 5 scales that has the same time. So this is a distribution that's equal, but it's not real. It's in the day you don't have 5 hours more or less of one consumption, 5 hours of the other one, and so on. So just dividing this into a normal in the same equity, you get a 49% of the savings. But the thing is that in a real scenario, in the real life, you get more savings because, for example, in our project, we aim to reach some areas where, for example, there are schools where they don't have access to internet, or some people that have lack of connectivity, and a school is not working, for example, Saturday and Sunday. So it would work at 10 watts during Saturday and Sunday, and the power savings can reach till 75, 80%, talking, for example, in a month, and that's heavy. So to end, and we'll do a small demo, we've done a pestle analysis. Talking about the political, we should talk with the governments because you need to have licenses for the spectrum. But this is not the most important thing because this is bureaucracy for us. But I'm sure that we could get some fundings because this project aims to reach children, aims to reach people who have necessities. So I think there are a lot of organizations that can help with this. In the economic, we have reduced the CapEx and the OpEx significantly, so these deployments can be sustainable in the near time and the long time. In the social factors, we aim to reach education, healthcare, and e-commerce. That are three areas that we think that can leverage a region or a rural or suburban area. In the technological, if we are talking about, for example, that we cannot reach some areas where, because of the geography, it's complicated, we have some agreements with Satellite, which is a company that we have strong relationships with, that they work with LEO satellites, so they could provide some seamlessly connectivity, but not with high throughputs. In the environmental factors, we open a path with this power saving that we're introducing with this scenario. We open a path to deploy solar panels to try to reach to a fully green network. And in the legal factors, we know that it's very important to take into account the security of the network, because you are dealing with the information of private or public people. So 5G networks introduce AES 256 algorithms, AKA algorithms, which are one of the most powerful ones nowadays for encrypting data. So in this scenario, we think are covered. And now we will proceed to do a small demo so you can see. Can I tell something?
Yeah, while my partner is preparing the demo, I want to say that for the AI developers, that I used Llama 3 8B bus model and quantified it in 4 bits. Why it's too slow having a 17, well, sorry, 17 billions parameters with models available? Why? Because we want just to do something so small that if you got sorry, teníamos tiempo, ¿no? What I want to mean with that, with more smaller and less data of model, it can be more trustable and more efficiently in time seconds, in real time. That is what we want to do with this project, analysis the data in real time.
So now I want you to pay a little bit of attention at what you see in the screen. This is the 5G core. It has nothing really serious in this deployment, but we have deployed an Open 5G core right here. So now we will do the deployment of what it would be in a real environment to deploy the RAN side, that it's always like the most difficult part of the mobile networks. So first of all, what we do is we start the near real-time rig. Okay, the near real-time rig is ORAN compliance, and it uses Docker. It's 7 containers of Docker. This deployment, it's a deployment in a one VM, but it could be segregated, or as we say, distributed in our world. Okay, so one ORAN near real-time could control multiple radios, not just one. So now we are going to connect Genode B into the radio. This is a Genode B simulated by the SRS RAM project, but this is the same software that goes inside of the Genode B that you got commercial off the shelf. You buy a radio which is compliant with this software, and you can run it. So as we can see, we have the N2 connection. The N2 connection is to the core, and we have the E2 interface that, if you remember in the presentation, the E2 interface was connecting the RAN with the near real-time rig. Now we are gonna run UE simulated also, which is into the database of the 5G core, to the UDM and UDR, if you are in touch with 5G networks. And as we can see, the PUE session has been established. We have assigned an IP in the subnet of the IPs, which is 1045.0.10. So this is our user right now. So now we're getting into the Docker container where we deploy X apps. If you remember yesterday, talk with Maria Lema, he was talking about the XApp. So this is the Python application where we run the code. And let me copy this one here because it's the string to run the code. It has some flags. So right now, well, I haven't showed this, but as you can see, the XApp subscription has handled, and to the rig, it has been associated a run into the to interface. And now, as we can see here, the application is retrieving the metrics in real time. Now the UE is connected to the network, but the UE, it doesn't have any type of traffic. The UE is not sending any packages. So that's why the value of 0. This value is calculated by the ORAN standards. Okay, so it's not calculated by us. It's just specified by the standards. And as you can see, well, the connection is not really, really good. But as you can see, our model has detected at some point that there is no traffic. So we need to change the power concurrency to 10 watts. So let's say, for example, that we generate some traffic. Okay. We start pinging to the core. Let's wait because this is long. There, it's still printing. Okay. So as you can see, it has increased to 78, 79, 80, 84. So our model has determined that it's needed to change the power concurrency to 150 watts. Okay. So let's say we create a little bit less traffic because this is a lot of traffic, let's say. 0.05. Sorry for the connection, but so now we're having like a traffic of 19, 20, 20. So we are changing the power concurrency to 50 watts. And this can be done thanks to the near real-time rig, which is pulling the metrics in real time. And then our AI model, who is telling you, hey, you have this amount of traffic, then you have to switch to this power concurrency. And with this deployment, we can save till 75%, 80% of the power of a single radio, which, by the way, one macro cell in Spain, with what it costs the kilowatt here in Spain, it's around 350, 400 euros a month. So maybe in other areas where the energy is less accessible, it's even higher. So this is one of the main problems on deploying this type of technologies in certain areas. And that's Enric. We hope you have enjoyed. And if you have any questions, feel free to ask us.
Thanks for that. It's great to see all the hard work from the past 48 hours in the demo. Can you talk a little bit more about your AI infrastructure? You mentioned you Llama 3.1. Why go for the Gen AI approach or an LLM rather than other types of ML?
Because I only want analysis. Like it's like simple instructions. If the traffic is going to one sector, you need to check other data, and with this data, decide what to do. That is translated to a simple instruction, by the way. Yeah, it's like I give to the AI some tools to get the both data, and depending of the data received, he is gonna decide something. That means that he doesn't need to create or doesn't need to. I don't know how to say it in English, but the AI needs to do what I want to do exactly. And the LLMs are famous for inventing data, and that's why I use a LLM very low and quantify it at very slow speeds. I don't know if I'm responding the answer or I misunderstood.
No, no, I think you explained. Thanks. Any other question?
So, what are the additional physical components that you would need to include in a deployment per tower? So, would you need to include any computing units? Would you be taking out compute capacity out of the tower? Is it decentralized compute based on the network preferences? How is the delivery mechanism structured?
So, good question, by the way. You have different types of deployment. Okay? You can deploy the CU in the same way, in the same physical location, in the same server than the DU. But this is not my favorite approach. If you have different, let's say we're here, okay? The tower or the CU is here, and we want to serve, for example, these two villages. So what I would do is use the same virtual CU to manage these virtual DUs. Okay? This is the most typical approach when you deploy distributed run. You use multiple DUs in one CU because the CU can support all the processing of the higher, the lower, lower layers, but let's say the lower of the higher, okay, layers. So virtual DUs can support multiple virtual DUs. What I would do is distributed runs, so have the same virtual DU and the radio head unit in the same physical location. So that's one server per DU and one server per CU.
So the next step, kind of calculating network capacity for instant delivery without latency.
When you're talking about latency, we enter into different things because latency, for example, can be achieved due to higher frequencies
Mhm.
or even in lower frequencies. If you deploy, for example, a UPF next to the location where you are having the applications, this is more like a network design and not rather if you deploy the CU or the DU in a way or the other.
Okay, so you considered it, but you'd have to implement it in a way that you don't have a delay, right, between the AI model functioning and then the what capacity being changed, right? Because I'm wondering what's the delay between the decision and the action, not to create a network connectivity issue.
Okay, I get your question right now. No, if you're talking about changing the power, no, that's a decision that we should plan. That's not a decision that must be done in order, like in 10 seconds, every 10 seconds, which is the power concurrency. That's not feasible, and that's not a logical approach. It is more like you should plan if we should change the power every 30 minutes or every 1 hour, or even if the AI model can, with more data of the same node, can more or less stipulate when the node will need more capacity or not. Because, for example, we're serving school, and we know that from 8 a.m. till 3 p.m., the capacity is at this. But then at 3 p.m., it gets low. So then that's when the AI model comes into the scenario to decide if maybe we can change the power in 30 minutes or 1 hour, or even get to know the hours where it will, yeah, it will have more power.
Anyway, the AI can multi-thread and parallelism different applications to different citizens with different information. That's not a problem for the AI. That's why using AI that can quantificate and tokenize the data in 1 million faster than a human or a normal PC can do it. Any other question?
All right, thank you very much. So once again, a small round of applause for the team. Congratulations and keeping fingers crossed for you. And now I'd like to invite the next team to present. And for everybody tuning in online, I will have a super short 1 minute break while we switch the presentations to the other team. So stay with us. We'll be back in 1 minute. Okay.
Rage on that beat, going crazy.
All right, everyone, we are back with the second team that's going to present today. The floor is all yours.
Okay, thanks. Hi, everyone. I'm gonna present to you our little project called Net Educate. In this hackathon, we solve different problems that have countries like from Africa, from South America, which is the limited internet, the restriction that they have to the educational resources, and the high cost of the data. Many of the time, the company don't want to invest in the infrastructure to bring the information, the internet to small communities. And the key question is, how can we provide quality digital education within full internet access? Our little project is based on this. We don't want to depend on the internet stability. For that, our project is based in different layers. First of all, we have educational content selection, which is with AI. This information will be stored in a server as cache. So, I don't know, one per week, one per month, this cache will be changed with information that the AI learn. Also, this information will be distributed around the local community, and the use that the community does about this website, how many times, how long, will be teach the AI to download similar information, similar websites. The data flow is first, the user, the teacher, the student will do input. I don't know, I want to study about equations. They will use a device, a mobile phone, something like that. I say, okay, equations. Then the AI will predict the best websites to learn that. This information, the content of the server will be updated. All the people, the little community will be have access with the internet to these websites, and how they use this website will teach the AI what the community needs about the information, about the data sources. We have two components in our systems. First of all, the local server that it could be Raspberry Pi or other open source infrastructure that could you do. In this server, we have the AI that predict which information is the best for learn math or something like that. Also, this information, as I told you, is stored here in the server and is updated one per week, one per month. Is distributed around the community, and in the future, these servers could be used as a node, like internet, with a radio antenna, could connect the different little communities to share the information that have the servers. Also, the other component is the client application, which is in the component mobile phone or something like that. Our system is based first in a proxy that use a fronted container, which is I don't know, you ask for a word, for a subject, for teach me about physics. The proxy that will do all the maintaining of the server, the log analyzer that will analyze all the use of the information that are in the server, how long they use, how many times, when was the last time that they access to the information, and the backend container, that is where the AI is and where is learn. This is an example of how the server store the information, the links, how many times the people access to the links, how the size of the information in the server or with each link, how long they are in the link, the cost of internet to access the link, and also the last time they access. Why this? First of all, we don't need internet. This could be a world when the people don't use internet, they don't need it. Second, the AI could analyze a amount of data to have the best information that we needed, and will learn about our usage. Then it's affordable hardware, as I told you, with a Raspberry Pi, some open source AIs you can do. It's peer-to-peer synchronized, improve the user experience. The people in these communities will have something similar to have internet within this. It's not the same, but they will have a similar experience. Also have a scalability, because I told you in the future, these servers could be used as a node to do a network between the communities, because it's easier to have a sort of information near from us that the closest antenna of internet. Also, is have customizations. Sorry, because AI will learn from us, from our use. Well, as I told you, they have different stakeholders and opportunities, which is the government, the school, rural schools, teachers, the organization that want to change something or do something for these communities. Also, some big techs if they want to collaborate or be part of this. Our idea will be three phases schedule. With the first is the prototype, the pilot phase, the second the expansion and partnership phase will be, and the last one will be the escalation of this, as I told you, the network of nodes. This is the presentation for now. I want to show you a little demonstration on how AI predict these kind of things. I don't know, as you see in the screen, I will say I want to learn about, I don't know, tell me something. Math? Physics? Okay. Mm, uh, Okay, now the AI is looking in the internet. This example is with three links, three keywords combination, because the AI will see different keyword combination and different links in the internet. Okay, that's it. Let me check. Math. The AI will create this simple, in this example, simple table with the subject, the keyword combination, and the links, and how many links it has. Well, the good part will be after this information will be downloaded in the server, and with the information of the server, if I can show you. Um, well, I show you before the information that the server have. We have here a little uh, little example that we create for this. This with the links of the searching of integrals and equations. We create a false data set of how uh, how they use the internet. With this, we'll reuse the AI to upload how many links we want to in the server, how many key word combinations we want the server to grow up the information based on our use. For example, in your case, we have this, um, uh, this one. This was the preset. And the AI bring us with some changes. For example, integral. The AI think that it's better to have separate with equations. It's better to separate equation between linear and quadratic equations. As you see, the number change, the number of links change, the number of combination change based on what the AI learn. Even the AI can decide to reduce it, as you see here. If they see that we don't use it, here you have more links, more sort of data, more combinations. Here you have less. I say, okay, they don't use this. So this is a little sample. It's a simple project, but I think maybe someone can do something better in the future.
Are there any questions to the team?
Thanks. Just, I'm sorry, I didn't really understand what this AI is doing at all. Do you think you can try to just explain like a situation in which the AI is doing something? Because it seems to me that you're just making a call to an LLM asking for links of a specific topic. I don't see the relationship between what it's being used and what should be saved versus what shouldn't.
We don't have here the other part that is the server is in the other computer, but we only put a single string. I don't know, as I told you, math equations. And with this, the AI will try different combination of keywords in the internet, and will find the best keyword combination to find the most used website internet. But the link is the server will allow this information. After that, when the people use the server, use the website, we will have the information of the use of the server. And with information, the AI will learn from this and will change how much information we need about each topic, each subject, for example. For example, we see that the people need more information about linear equations or something like that.
When we spoke yesterday, you were exploring more the angle of network observability and learning the type of content that is observed on a network. Can you talk to us briefly about the pivot? Is that something you ended up building, or did you change your perspective into educational curriculum strengthening?
We changed a bit because we try to use some open source libraries about all the trends to know the relation between the different topics. But we didn't. It's not working now.
Got
These libraries.
Okay. Any other questions?
So if you had another week, right, to work, which you do now, what would be the kind of next thing that you would add to make this more compelling or better? Like, do you have some sort of a short roadmap in mind?
Yeah, the next steps will be have a data set of the whole internet. The question be cool about how the people search for each subject, not only about AI decide of the keywords. With that data set, we will teach the AI not only to say, okay, find this in internet, these words, find the best results. Will we? Because sometimes it's not the website that most people use it. Maybe it's 100, something like that.
Thank you very much. And let's give a moment of applause to the team. For everybody watching us online, we'll be back again in 1 minute once we set up the next team that's going to present.
Rage on that beat, going crazy.
Welcome back, and let's welcome the third team of the day. The floor is all yours.
Thank you. Right, so hello everyone. We are Team Unisphere, and we were on the procurement and policy track. And our solution is an AI-powered, transparent procurement for public sector connectivity. First, I would like to start by introducing our team. Just to share our story first, me and Melody, we met in Geneva in the first hackathon, end of January. And we'd never met each other before, so then we just somehow found the team. I think you found my Discord message. And because we were both going to be on site, and that was important for both of us, it kind of felt good that, okay, we could be a team. And then we won. That was a complete surprise, but yeah, it was awesome. And because of that, we are now here in the second hackathon, and we have expanded our team. So it's not only me and Melody anymore. We have 3 more team members who joined, who are also here on site, and come here. So we have here Donaldo, there. We have Lucas, and we have Mauro. Yes, and we represent 3 different continents, so Africa, Europe, and South America. And we all come from different countries, basically, so we are multicultural. Quite a welcoming, inclusive team, I would say, because, yeah, we are Unisphere. So they have strengthened our team, and so I just wanted to give this little intro so you know our story. And we've been vibing in our own corner here in the space, and listen to some Nigerian music, and it's been great. So actually, we kind of came a team, I would say, during this second hackathon. So that's what we did. So next, okay, let's go to our problem statement. So procurement. Yes, so sorry about that. Government procurement, especially, they are struggling with creating comprehensive RFPs. It's lacking some standardization, and it's time-consuming, and also inconsistent. These different organizations and departments, and there is some cost inefficiency as well involved. So we want to improve this with the help of AI. Because all these issues, they lead to inefficient use of public funds, procurement delays, and suboptimal vendor selection that might impact project outcomes. And for that, we kind of evolved our solution from the first hackathon, which was an AI-powered procurement platform, kind of all-in-one. So we kind of laid out this big platform with procurement, RFP creation, and submitting bids for vendors. And also we had blockchain tracking all the events for transparency. But based on all the feedback that we received, we evolved from there and decided to focus on specific areas. And we call it LLM for Procurement Intelligence Suite. So it has several things which Melody will next show you. So I will hand the mic to Melody.
All right. Anna's already explained this. So a key feature you see, well, basically what we're trying to do is we're trying to train or fine-tune an LLM with procurement data, so that it's learned specifically to be able to appropriately provide RFP analysis and bid evaluation. One of the things we noticed in our solution is that we were using a generalized LLM, which was OpenAI GPT, and we realized that in as much as it's a very good LLM, it sometimes doesn't exactly provide context when giving documents or when giving a text. Sometimes it hallucinates a lot for RFPs, evaluations, and the rest. So in this regard, the key features we're focusing on is RFP analysis. And in our RFP analysis, the implementation is we do requirements matching, passing of documents. So the passing of documents is conversion of a document to bring in extracting the text, and the text goes into the RAG system, which now is order to the trained or fine-tuned LLM, and it's like the action between both parts, so that the results that you're getting is it's coming from a vectorized database that has been trained, or that has been built perfectly based on our RAG. Yeah, so gap identification. Now, this is the very important part or very essential part. which is, as we have from discussions we've made with people in the industry, we realize bid evaluation is one thing which affects the vendor and also the person who the buyers, right? Because in the public sector, the bid evaluation part is kind of privatized, in the sense that no one really knows who's. I mean, that kind of information is what it's done in a very closed system or closed way. But we are trying to support the person who is going to be doing the bid evaluation, not entirely take out the evaluation from there. So we would make in analysis on this, and within bid scoring based on the RFP documents. So it takes different text inputs or that text from documents that are submitted from the bids, and it's able to make bid analysis. So it scores the bid, and we added a weighted evaluation. So the weighted evaluation here is 40 to 60 from the RFP document and 40 from best practices. So we did a research. So did some research. We read through some documents and got some best practices of evaluating the bid, and that is what we're training, what we train our LLM with. So here we did strength and weakness analysis. So it doesn't make sense to just give scores and evaluations. So we need to be able to explain the strengths of the bids, the weakness of the bids. So the LLM will not just give you the scores, tells you what was noticed in this piece, and so, like I said, it's assisting, not giving definite results. And I've explained the best practices integration. So the implementation is so we developed some task templates, instruct tuning templates. So after processing OCDS, we did some data processing, produced different data as regards procurement in connectivity, and also specific to country, Zambia. So ideally, how this will operate is that you can put in the country, and you can query the LLM, the fine-tuned LLM, and it's going to work based on that country's data as learned about. So because we understand that how the evaluation of LLMs in different countries changes. For example, in Zambia is mostly based on price, and for other countries it might not really be like that. So this was one of the reasons why we said we have to think about putting country in there. So evolution, Anna already explained a little bit of how we evoluted from our evolution from Hackathon 1 to Hackathon 2, and our initial concepts. And our initial concept is narrow focus, LLM trade for RFP creation and bid evaluation. And now we moved from GPT 4.0 to IBM Granite, which, as we continue building, we think maybe it's too early to try this solution, or try what we want to do with IBM Granite. So maybe we'll be trying with other LLM to see what we can do with that. Real world data, which is very interesting. This took most of our time because this took most of our time because we were trying to do most of our time spent on processing data from OCDS and integration strategy. So we would build APIs that would work with our LLM so that it is integrated for every system. So one thing we noticed is that we're like a small fish in a big ocean of many big companies that does procurement systems. And public sector, they go with the big guys because of the believe in privacy and the rest. So we are more concerned about, okay, how can we support the big guys? So with this system, they can access our system via an API, and we just provide them this service of evaluation, analysis, and like we said, is a suite. So in essence, we can upscale this and add some other additional features, like maybe integrating the blockchain into this suite also, so that and there's no thought through now, but yeah, we have that in the pipeline. The technology stack, as you would see here, very beautiful Hugging Face, EFT with Laurel, that's for the fine tuning, and yeah. So this is the link, Hugging Face. So I should say this for now, so it's not misleading. Sadly, we weren't able to deploy to Hugging Face, and as we speak right now, the system is training. So, we weren't able to finish this, and the personals you see here, we try to envision our personals and see who we want the system to be for. And as you see here, we have procurement officer, technical evaluator, the ICT and security officer. This is important because we're talking about security here. UN wouldn't want to give open data or data of their bids out. I don't think we see those things. So security is very important. And that's why we look into how we can tell this to an ICT security officer and say, our solution is a good solution, you know. The vendors the pain point is long procurement time. We spoke with someone who under this category, and we gathered that from them too. The personal analysis, as you would see here, we considered political, economic, social, technical, technological, environmental, and legal. And as in legal, you see explainable AI, we don't want anyone coming to us and say, we made this happen. You know, so we had to use explainable AI in our solutions. So if you do make a decision, we can tell you we only saw this test, made your decision. So, sorry. Possible challenges, security is still a major challenge because in as much as we make it an open source LLM that can be self-deployed in your environment, it's still a mystery on how the data works. So we can't really tell if Granite is actually taking this data or they are truly sincere that this data is self-hosted, you know, because you're interacting with an LLM, and in as much as they tell us that it's self-hosted, so your data is going nowhere, but you are not 100% sure about this. So in this regard, security is still a problem. Structured data, like I said initially, most of the time was spent in trying to organize this data, and so getting structured data is problematic. So maybe future we'll spend more time now looking into different data sets, databases, so we can have a centralized structured data set for this. So in future plan, security, new features, human in the loop, and smarter models. And yeah, this is the very beautiful thing, as you can see. And yeah, our rules. Thank you.
Are there any questions to the team? Zero questions? I believe that means that the team covered everything they had in the presentation, or is there a question?
It's just curiosity. What do you expect from this project in the future to do?
Okay, that's a very good question. If I wasn't rushing, I would have probably showed you the future plans. But the plan is, like I said, we can't build a system that is where the big dogs are already playing, or we can support the big dogs. In essence, we want to build an integrated software, so a software that's integrated. So an API endpoint, a procurement LLM. In my opinion, what we want to do in general is a specialized LLM, made specially for procurement services. So we move from just being able to answer questions, evaluations. We go from there to being able to do all small tax procurements. So far, that aids or speed up the time in evaluation, speed up the time in operations generally. So I already uploaded that. I would have showed you our GitHub. So we have like this index files. Sorry. I can just quickly show you this because I'm still presenting online. So yeah, but I mean, maybe later after this, I will show you the GitHub repository so you see the full plan. So after the first hackathon, we've planned more of this. So the idea is that we have our tool, and we still have our own system. is a procurement system that is blockchain powered and AI and blockchain powered.
Thank you very much. And I'd like to remind you all that regarding this repository, on LabLab AI website, when you go to AI hackathons, even if the hackathon already finished, there are the links where you can actually check the projects. So feel free to check them out and discover what has been built during this hackathon. Is there any other questions to the team? If not, I would like to welcome Pavelchek, the president of. First, I'd like to have a 1 minute short break to actually switch the screens, and then the final words from Giga and United.
Rage on that beat, going crazy.
And we're actually back with a small bonus. There is one more team that will present their project. So,
hello, thank you very much to be here. I will try to be brief. I want to pass to Irina.
Hello, we are Jose Antonio and Irenia, and I have studied pedagogy, and he's studying physics. And we have more people in the team, but they are online. And we built the project AfriLearn AI Tutor, Transforming African Education, that it's an AI platform to help the African students.
Thank you, Irina. The idea is about to improve the educational processes by giving some type of personalized tutorizing for the students. We are addressing to the people who are studying now education at Kenya, and we are thinking about the problems related about the poor network and the issues with the power supply of the servers and so on. The idea is to mentorize the school children and all other the levels of education in order to achieve a better success rate and detect things like abandon of the school, mistreatments and bullying and so on. Okay, we know that for personal tutors in that areas, it's sometimes a bit difficult to localize them, and we are going to make it easier to find the right tutor to the school to the children. And the other barriers are languages, different languages in different regions, like Swahili, French, English, and this is a way to leverage these natural barriers, language barriers, excuse me. And the other purpose is about I talked about before about power supply limitations, poor network. This all is we are talking about a model that can be standalone while you are not connected, and you when you get connection already, you can synchronize your work. Okay, we have spoken about some of these things. We have support for initially for English, French, and Swahili. We have integrated some voices to speak the right pronunciation, not like me. I'm sorry for this. We provide some guidance for the offline mode and some career guidance from when you have the connectivity. Well, as is, we are working on to expand the language supports for many regions of Africa, and the gamification of the education. I think to play with simulations is a better way to play with things like physics. If you have ever played a flight simulator, you will understand physics very in a better way that you can understand if you only are sitting and see how I speak. Therefore, it's the gamification. It's a part of the educative process that I think it's a key feature of our project. The mobile app is in the, we want to develop. It's the important, very important because it's the key to stand alone when you don't have connectivity. You can still work by yourself. And I think it's important because things like rain can easily fall down all the internet, and even the cuts in the power supply can fall down the servers. Thank you. I think it's that's all for now.
Thank you very much. Are there any questions to the team?
Which track did you align your project with from the hackathon tracks?
The track?
The tracks, yeah. We had several tracks for the hackathon. There are 4 tracks. Just wondering which one you think the project aligns with.
We think the project has two layers, and we are very deeply concerned about the connectivity in zones like Kenya, like Ghana, like Nigeria that I was working few time ago. And the main problem is if you are wanting to work remotely with that places, you will find technical problem. You don't have electricity supply, don't have power supply, you don't have good connections. The bandwidth is very low. There is a high latency. This is a layer that we can right now in a couple of days. It's impossible to afford in a single one project. And the other layer it's about to supply the deficiencies in the public education about the personalization of the tutorification. That's our main attack goes by this layer. However, the first layer about the connectivity is the main concern, and we are working hard to make it this personalized pricing available in a standalone offline.
Thank you.
Thank you. Are there any more questions?
Sorry, I have a question, and I also have a little bit of suggestion or contribution, if you don't mind. Okay, I'm kind of interested in a topic like this because I had formerly done something in this sector. I had a startup on the sector initially. Also, my first question will be: how does the guidance offline mode work?
Okay, the guidance offline it's very difficult in the sense that we don't have. It depends on the local we can install in the application for the mobile. I think the application we can run a local model that can be limited, but still powerful to help you. I think it will be better than nothing, and it will keep the track when you are offline. Because I say that the mobile app is not developed yet. However, it's a key feature to implement this project and its viability.
Okay, thank you. So now my suggestion, or not suggestion, my suggestion, yes. So my suggestion would be, or what I want to say is, so one of the issues that we noticed in cases like this, or in a system like this, is connectivity, as you said, is a problem. Now, if I would advise things in places like in Africa or probably Nigeria, specifically, always some points that has high network coverage more. And let's say, for example, university settings inside the campus, we always know the places that has more networks and more connection points. So if you can ML model that can, while they are using the system or using your software, track the network speed at every point in the university, then you can always predict where the user is going, or when the user wants to go out. You can already check if you are going to some place, and then it tells you, okay, you are, I mean, somewhere in the system, you know, points in the university or in location, different locations where network is strong or network is bad, and then you can always switch across offline to online. So the model is helping in predicting the network or using to interpret the data of all the network access points or network constraints in different regions in a particular city, locations, and stuff. And whenever the person is, it can already tell them that okay, you won't be able to access a location because of this. So, because I've had too many experiences where we go to hubs, we already pay before time to hubs, and when you go to the hub, you don't have network coverage. That's because of the location the hub is in. So it becomes difficult to find a good hub in around school or a good location around school where you can actually stay and do your work. So if your solution works, if you have the app now you can get this data of the network speed and then learn from this data and do some prediction analysis, competitive analysis.
Great. That's a great question, a great suggestion, because I think we talked about this yesterday with some of your mates. And I think a predictive model that can predict the points of where the signal is very more intense will be a good thing, and a model to predict if even the power supply will be things like that will make this project more viable. Thank you very much.
Thank you very much. These were all the teams that had a chance to present on site. Of course, there are more teams who submitted their projects, and judges are now in the process of judging. So as soon as we have the results, they will be shared. And now I would like to invite Maria Antonia Bravo from Giga to give the closing remarks.
If I'm tired, I cannot imagine how you're feeling, because I just have been standing around watching you do amazing work over the past 48 hours. And I would say using 10% of my brain power rather than 120. So I just wanted to close by expressing our gratitude for you for coming, for dedicating all this time to tackle these questions with us. Giga is as I mentioned before, is a joint initiative. We're based in Barcelona. We have a technology team based in Barcelona. We're constantly looking for AI specialists, data engineers, developers to come join our team as we build gov tech that different governments across the world use to make connectivity procurement more efficient. Connectivity procurement, but also other uses. I also wanted to express my thanks to NTT Data and the NTT Data Living Lab for hosting us and having this incredible venue over the past couple of days. Without further ado, just closing and to say thank you. Thank you very much.
Thank you so much, Maria. And now I'd like to introduce Pavel Czech, the president of New Native, for final remarks.
Hi, everybody. Thank you very much for completing your work. Amazing effort. We have, together with the on-site and online submissions, we have 60 new projects that will be now added to the pool of consideration for Giga. And with the support of NTT and other partners for Giga, I hope we'll find projects that are really further development and implementation. I hope you had fun here and enjoyed yourself. And obviously, you don't have to go home. You can't stay here, so, as they say in the movies. Yeah, thank you very much for joining. Thank you to the LabLab team, those here supporting you, to all the mentors, all the people that run the workshops, the experts, the support teams that were in the office over the weekend. You made an amazing sacrifice to complete everything, and there's another 10, 20 people needed to support you being here. So thank you to the organizers as well. Okay, great. Have a good day.
Thank you so much. That was everything if it comes to live streams straight from Barcelona. And good luck to all the participants. Bye.
Rage on that beat, going crazy.